Let's talk about a recap of what we learned so far. So, we started with the basics: how to open the program, how to start a file, and how to make our own adjustments to the user interface. Now, it's always important that you're comfortable with your work environment. If it's complicated, if it's hard on your eyes, if it's hard to find the tools, you're not going to want to use it. So, of course, you got to model a little bit, but you have to spend the time to get everything usable for you. I see a lot of people when they start to use SolidWorks, they just leave it how it comes in. And they might have 15 tabs down here. They might have a bunch of toolbars floating around. I refresh everything every time I model. Oftentimes, I will only keep the features and sketch tabs on. If that's all I'm doing and I don't need to see anything else, I'll do that. Because I've been using SolidWorks long enough, I turn off the large commands and I minimize it because I know what everything is. I know this is mirror, I know this is pattern, and so on. So that's how I like to work. And I feel like it's important that people get into a case where they like to work and they're comfortable. Now, after we started talking about the user interface, we got into sketching and we talked about a lot of different things in sketching. And the most important things that I think you should come away with is understanding what makes a fully defined sketch, whether it's fully dimensioned, whether it's adding relations, and how the sketches update when you change dimensions, making sure that you understand that when you change this dimension, how it's going to affect everything else downstream, because that's going to be the most important to making a nice, solid parametric model, having that nice, fully defined sketch, and not being surprised when you change dimensions. Now, after we talked about dimensions, we got into model. And the first model that we did was this machined part design. And it's really not that complicated of a part, but we took a look at a lot of different things. We looked at some different features. We looked at some new things that SOLIDWORKS did for us in 2016, like the threads, which are pretty cool in their own right. It allows us to add a little bit more detail that looks better when you do things like visualize it or add renders. We looked at a lot of the different sketch tools that we were able to use, different features like patterns and how we can update those and change those moving forward. So we designed our machined part. And after we designed our machined part, we talked about designing a molded part. And the example we did was a drafted wheel. So we looked at what it meant to create a template with some draft properties in it inside of our equation manager. So we had things like draft set to 1 degree, our wall thickness, our rib thickness, and all that information was in there, so it was available for us to use, and we were able to link it to our features and link it to our sketches pretty quickly and easily. So inside here, we understood how to do things like make our drafted part, and we understood how to do things like evaluate it to make sure it had draft. And once we moved on from creating our drafted part, then we started to talk about sheet metal and weldments. And this is a pretty big section because SOLIDWORKS does this pretty well. And over the past couple years, they've been really hitting the ground hard and adding new functionality for us to make it easier for us to design these sorts of things. Now, we did this sort of box enclosure made of multiple parts, and we added another part to add some welds and add some weld detail on there. And we really looked at the creation of these features and how we can adjust them and change things moving forward. So we're comfortable with the user interface, we're comfortable with sketching, and then we're comfortable with making some basic features for machine parts and sheet metal and welded parts. Now, from there, I took you into a topic that is typically left off of a basic series, and that's complex surfacing. Now, I really like complex surfacing. Not a lot of people like to do it because it's not as easy as doing an extrude here, a fillet there. It takes a lot more planning, a lot more work, and a lot more understanding of the features. But we went in with a basic approach and we learned how to do things like make projected sketches and do projected curves that made these nice 3D curves based off of simple 2D sketches. And that allowed us to do things like control the curvature and play with relations, making sure that our guide curves pierced. And we were able to see how different surface operations handle different aspects, different features, and different ways that we had to patch things. We took this complex example, we made a mouse, a more recent common shaped mouse, and we made something pretty cool out of using those features. And after we talked about features, we jumped into learning how to edit our parts, edit our sketches, and really see what happened when we got warnings and we got errors and different ways that we could figure out where those errors were and hopefully repair the files. The goal is to never have those errors, but honestly, that happens. It happens no matter how hard you try, and just understanding how to get back to them and figure out how to get around them is a very important aspect of parametric modeling. At this point, since we had talked about several different types of modeling that you could do in SOLIDWORKS, and we talked about how to edit the individual models, we jumped into making an assembly. Now, the assembly consisted of a couple different components, and we talked about the difference between in context and actually bringing in an assembly component, a subassembly component, or an individual component. We talked about doing a layout sketch. We talked about using blocks. And then we talked about actually adding mates between our components. So we had some motion, we could move things around and really get the dynamics of how things moved in 3D by putting these components together. And even though it was a little bit more of an advanced topic, we talked about doing motion studies and assembly references and how components were referenced and put together, and really just took a basic look at how we could expand on what we already knew about assemblies. After assemblies, we took a few components and we talked about visualization. We talked about different ways that you can view them on the screen using things like real view graphics. We also talked about different ways that you could use things like the display states and configurations that would allow you to change how assembly components looked or how parts looked based on the configuration or just based on a display state you selected. And we also took a look at actually doing some Photo View 360 rendering. After we did the visualization, we then jumped into configurations. Configurations are very handy, and we took a brief look at things like design tables, how we could do assembly configurations and exploded views, and the sorts of things and ways that we could configure sketches and features and components to make quick use of adding multiple versions of our parts, adding and subtracting features and suppressing things, and just modifying dimensions in different configurations. So, very powerful stuff. And again, a little bit more of an advanced topic, but easy enough to understand, especially once you have the basics down and understand things like naming your dimensions. So they're much easier to understand what they're relating back to. After we left configurations, then we started talking about drawings. And detailed drawings, again, are still a big part of the industry. A lot of people still have to do 2D paper drawings for a lot of their designs. So we took an introduction to drawings and creating your own drawing templates, and then getting into creating views and doing dimensions and annotations for those, and ultimately seeing how we could output that information, saving as a PDF, e-drawing, or simply just printing it out, different ways that we could do that. And drawing was really the last topic that we had to talk about. And then I just did a brief couple videos talking about additional tips, different things that you should just expand on and understand when you start working in SolidWorks, things like additional add-ins that you have access to, like Scan to 3D, or even if it's going into DriveWorks or looking into some of the Simulation Express, or going into the SolidWorks tools like Property Tab Builder or the Task Scheduler, all that information that's already there. So definitely the recap of lessons, you should understand everything that we've gone through. And if you have any problems, go back to those lessons and just make sure that you're building upon them correctly. The sketching is definitely the starting point. Don't go past sketching if you don't understand it. You have to understand the base of sketching, and then you can move into it. If you don't understand complex surfacing, that's not a big deal, because if you don't do complex surfacing, you don't need to know it. A very small subset of people actually do, probably less than 10%. Again, it's a more of an advanced topic. If you don't understand weldment and sheet metal so much, if you don't do that, again, that's not a big deal, but the basics of the sketching has to apply to everything else downstream. The surfacing doesn't really apply back to machine part design, but sketching applies to every facet of it. So everything builds on it in some way. Make sure that you understand everything that we've gone through at least a little bit. And if there are areas that you want to build on, go back to those sections and then start to play around with those things.